Welcome to another hands-on video about the Fitbit Web API in Delphi. And today I'm going to show you a video how we can extend the existing class that we built in the first two parts or the first two videos of this playlist. And we're going to extend the class so that access keys that have been retrieved by connecting, that means the user provided the username, login name, and the password, and the access token has been retrieved from the web service, and you have the ability with the FNC Cloud Pak to store these keys and automatically load them the next time your client application is launched. And if the access key is valid, different web APIs have different lifetime for their access tokens. You don't need to ask your user to authenticate again, to enter the username and password again. Your client will still be able to access the application. Of course, this brings some remedies with it that you have to take care of, because your service class has to be able to refresh a token, meaning you need a refresh token to ask for a new access token, and that whole process is being explained in this video in great detail. So right now, the connection involves that you authenticate, log in to the service, you provide your username and password, and you get an authentication token, and then your client application is able to request the access token. And when that access token is retrieved, you test this access token if it works. If it doesn't work, you request another access token, and so on. That is the current implementation. This implementation is done whenever your application restarts, meaning the authentication and the request of a new access token always happens, and that's not always necessary, especially when you're developing a client that requests data in regular intervals. Sometimes the validity of access tokens is being extended, so you might never have to re-authenticate during a day or during 2 days. So this is actually something that gives you the ability to close your application, restart your application, and continue where you left on. In order to take the next step, we need to introduce the term of the refresh token. Well, this is also a token of refreshment of on your screen, but that's not the kind of refresh we're talking about. We're talking about the technical term about a token that is used, that is being sent to the web API, and this token then refreshes the current access token. And this gives you the ability to store an access token. The next time you start your client application, you try using it again, and if it doesn't work, then you can use the refresh token to refresh your access token. The web API makes the decision in that case if the user needs to enter username and password again, which is in accordance with the setting on the provider's account setting. So if you, for example, on Fitbit say, hey, store my username and password, it can be that you don't have to enter your username and password on the same computer in a long time. But still, your client application, the Delphi application, has to request a new access token, most likely every day. And that is something that you can also influence with parameters on your request, where you can ask that an access token is valid for a certain amount of time. And different web APIs have different means to determine the validity of an access token. With the TMS FNC Cloud Pak, you can store these keys, the access keys, easily in the Windows registry in an INI file, or use a T-data source to store it in any of the databases that your database framework supports. This gives you great flexibility to store your access keys for the next session of your client. As said, in this video, you'll learn how to extend the class in order to support storing and reloading of these keys. And we're going to look at the Windows registry to see the result of the keys being stored. And of course, we're also going to expand the Fitbit Web API component that we built to support the refresh token. Let's start with the easy stuff, the saving and the loading. If we click our Fitbit component, which we built, we can see that you have different abilities where to store your keys. If we look at the properties, we find the property persist tokens, and this is exactly where you can set the configuration where your tokens are supposed to be persisted, and you can also say which tokens are supposed to be persistent in accordance with the laws and regulations that your client is used in. For example, there might be some law prohibiting you to save the secret key inside of the Windows registry or in a certain database, so you can individually choose which of your authentication information is being saved in the registry. But not only the authentication information is being saved, in particular, you store the information that is being retrieved from the web API. That means the access token and also the refresh token, and all those things are being stored. So you can think of it as if you store this information either in a database or the registry or an INI file, if your client application is being restarted, it behaves exactly like it never was shut down in the first place. That's the idea behind this. And what I did here in this example, I specified a key, software Flix Engineering Fitbit API. I selected the location as PL registry. And as you can see, you can also do PL database, PL INI file. If you specify PL database, you have to define the data source as well. And the section is also used for the registry, not only the key. So that is a little bit confusing at first, and that's why I'm going to show you the registry right away, what it looks like. So going over here, we go to software and then Flix Engineering, and then to the Fitbit API, and then the next one is the T Fitbit service. And here you see all the information that has been stored by the service class. And another nice thing about it is everything is stored encrypted, meaning if you look at this information right now, it does not mean that these values can be used right away. These values are all encrypted, and the FNC Cloud Framework does that for you. Going back to Delphi, we have to insert the calls in order to make the persistence happen. So just setting the persistent property on the control right here, just setting persist tokens is not enough. You have to do more. You have to call a method to load the information when the application starts. And of course, you also have to call a method to store the information before the application is shut down. And the best place to do this is, of course, in the events of the main form. So let me make this bigger again. You go to the onCreate event of the form, double click here, and you see that I inserted the line service, which is the Fitbit service component, .load tokens. That is all you need to do. If you want to make changes to the persistence at runtime, you can of course do that. You can say service.persist tokens and then you can make changes to the data source, to the location, and so on. It doesn't have to be set at design time. You can also make changes as runtime. The most important thing is before you call load tokens, obviously. And the same thing you can do in the case that you receive new data from the service. And when is that the case? Well, after you connected. You don't have to wait until your application is shut down. You can actually do it much sooner than that, because you retrieve the access token and the refresh token, and all that information is at hand as soon as your service is connected. So I went to the Fitbit component, to the events, and picked on connected and added a line after being connected service.save tokens in order to store the information to the registry. That's it. So that's how easy it is. 2 method calls and you have persistence for your services. And let me demonstrate it right away. And I promise I won't move the web browser. You see, I don't have any web browsers open. I click connect. And what happens now is the web browser stays closed, because we don't have to authenticate, no authentication token is being retrieved. I can click heartbeats right away, and here's the heartbeat diagram for today. So there is no new access token that had to be retrieved. And if you still don't want to believe me, we close this application, we go to the registry, and we delete this key. We delete the information that we have stored using the component, and we start the application again. And now I click connect, and the web browser launches right here, and I get a new authentication token, not access token, and here application successfully authorized, and then the web service API is asked for another access token. And as we are connected, you can see that here, heartbeats, I can check them again. We also have the new information. If I press F5 here in the registry editor, we get the new information with the new access token and everything else. So this is really how easy it is to implement a persistence mechanism for your service classes, that the authentication using the browser doesn't have to happen all the time. But the biggest thing I have not talked about yet, and this is definitely not the time to shut off this video, because right now this wouldn't work. And the reason is pretty simple. The first implementation of our service class did not use the refresh token. Or to say, I used the refresh token, but I didn't use it for the purpose it was intended to be used, because we didn't use the persistence, so it was fine asking for a new access token for each session. It worked perfect. But now we have to implement the refresh token. And in order to do that, we have to expand the Fitbit service class. And sadly, the documentation is a little bit slim on that, but I'm quite sure after this video, these details will get added. And because the reason for that is not that TMS didn't think it was important to be added. No, the reason is pretty simple. Not a lot of services use the refresh token primarily, and that was the reason when the documentation was written at the time. It was not considered that important to overwhelm users in the beginning. But now more and more services offer this functionality that I expect this to be added in the near future. It is in the documentation, but not in the introductory example, because in order to get started, you don't need it. So that is the reason why you might not see it right away, why I missed it at first as well. But if you look deeper in the documentation, you can find all the necessary information. And another thing to remember with refresh tokens is, and this is where it gets a little bit tricky, again, you have to look at the documentation from the service provider, how to refresh a token and how the mechanism works. Otherwise, there is no way that every service is the same way. That's how honest I can be with you. There is not the one solution that will lead you to the goal. You will have to look at the service API documentation, and that's also how I got where this component is right now. So the first step is you need to also override the method called retrieve refresh token. So far we only have retrieve access token and get authentication URL. We also need to implement the method retrieve refresh token. It is defined in the base class of the cloud package, but we need to override it and provide the implementation for the Fitbit API service. How can we do that? Well, we look at the documentation and find out how to retrieve a refresh token. And to retrieve a refresh token, we use the same endpoint as for the access token, and that is what I stumbled over at first. Looking at the documentation, I found a chapter which is called Refreshing Tokens, and this documentation clearly states you go to the very same endpoint that you retrieve the access token, but, and this is the big difference, you don't have an access token which is valid right now because you found out that your access token is no longer valid and you need to refresh it. So what happens? You have to create an authorization header in your post that uses the basic term or basic word followed by the base64 encoded string that is built of the client ID and the client secret. This is the same approach that we've used before, just now in order to get a new access token. And also the body of the request, of the post request, is a little bit different. We don't use the grant type request token. No, we use the grant type refresh token. And then we specify as a parameter the refresh token. And in Delphi, this looks like this. In order to retrieve the refresh token, we build the request exactly as I just said, content type, authorization, basic, with the method that we wrote in the first part of the video, and then grant type, refresh token, and the refresh token is the access token refresh. And that is something that, once again, the base component does for us. When we authenticate, the service also basically gives us the access token refresh property. It fills us with a value that we can then send in order to refresh the token. And the second method that we need to override, you might think, is the method to evaluate the refresh token or whatever. No, we don't need to do any of that. All of that, once again, is handled by the framework. So we just need to execute the request, and as a parameter we say do retrieve refresh token, and that is once again a method that is provided by TMS. We don't have to implement that ourselves. And that is how easy it is to implement the refresh token. But now to the final step, the testing of the token. Because right now in the implementation that I've shown in the first part of the video, we tested the token using the refresh token and it worked just fine because we did not use the refresh token functionality. But now we actually use the functionality as it is intended. So what we do is we test the access token using the authorization header with the access token that is supposed to be tested. And in this case, this generates the bearer and together with the access token. And the path we use to test it is the user profile, because only if the access token is valid, then we can request something like the user profile, etc. Or I could have also used the heartbeat endpoint. I just wanted to use something that is available without any data collected with the Fitbit, and that is the user profile. The user profile will always be there. So that is a prime candidate to use to test your tokens. Even, for example, if you use the heartbeat endpoint to validate your access token, you might actually get the reply that there's no data. But the reason that there's no data is not that your access token is invalid. The reason is that you don't have any data in that area of the application. So this is just an example how you can test your access token if it is valid or not. And another reason why I picked it, it is just the URL and a GET request. There are no parameters apart from the access token. Of course, it's very simple to use. And then I used the test tokens request result event again, which calls the method that is also again implemented by us, the retrieve, where is it? Right here, get test tokens result. That is also a method that we implemented in the first part of the video, but now we have to change it because now the result that we get is the user profile. And the easiest way for me to do that is by showing you the results in Fiddler, because otherwise I'm just talking about theoretical things and you don't know what's going on. So let me show you what we're talking about. Here we go. When I connect, this is exactly what happened. So this is the only request that is being sent to the API when we use the persisted access key. We don't have any authentication. We just go right away to the test, and the test gives us the information about the validity of our access token, because we wouldn't get a result if our access token would be invalid. That is the easiest way to explain it. If our access token were no longer valid, this request would not yield all the information of the user profile. It's as simple as that. So with that in mind, we then can simply check, like it is explained in the documentation, if we can find the JSON value user, which you see right here. If that is found in the result, we can set result to true and go on. I added something else in the source code of the component, which I will not go into in this video. I also added a class for the user profile information, but that is nothing new for you. Basically, I created a T user profile class, which you'll see right here, with all the information that is stored in the user profile. And then I also added the necessary methods that you can see right here to transfer the data from the JSON into the user profile object that is being created here. And that means the service class now also carries the user profile of the user that you could use later on. So this is something else I want to communicate with this setup, so to speak. I also use the user profile because the user profile information is something I might need at a later stage. And this way I use something that is necessary to test the validity of my access token to actually get information that I might need at a later time at the same time. So the request to test the validity of the token is not in vain. It's actually quite useful, because with it, at the same time, we get all the information about the user that is connected to the service. So just think about it, that you, even though you don't need to do it, it is nothing that is required that if you make a request to the web service API that you only make requests that are useful. You could pick any other endpoint in the web service API to test if your access token is still valid. You just have to find a combination where you know that your access token is no longer valid. In this case, it's as simple as looking at the response code, because if the response code is not 200, okay, then the Fitbit Web API tells me your access token is expired. I think the response code is 401 if it's no longer valid. If it's 200, I can then go into the JSON and check a little bit deeper. If the user tag is there, then I say, hey, if the user tag is there, I'm quite sure my tag is valid, and I can go on. And of course, because I want to read the user profile information, I also create a new TUser profile object and pass the JSON value into the create constructor. I overwrote this, and it will automatically read all the values into the object from the JSON. Another thing, and that is really the final thing that I had to do in order to read the user profile information, that is something I missed at the beginning. So let me go back to the request in test tokens. And that is something you have to be aware of with any web API that you're going to use. I'm going to request user information, profile information. And if you go way back in your memory to the video when we built the initial authentication call, when the user gets the username and password dialog, There's also information given what the user wants to, or the web API offers, what kind of data is being offered to the client, so to speak. We needed to specify, in addition to the endpoint, we also needed to specify what kind of information we want to request. And when we implemented the method getAuthenticationURL, at that point we just added heart rate. You can look it up in your code. It was just heart rate. And now to the scope we add profile, because if we look in the documentation of the Fitbit web API, we need to specify profile as well if we want to access the user profile. And this leads to a different login dialog for the user that gives us permission to access it, because it not only lists the heart rate API, it will also list that the client wants to access user profile information. One final thing, we have to wrap this in a URL encoding function, because the space here has to be encoded. I could have also written, I think it's %20 or something like that, but I preferred my source code to be readable, and that's why I selected to use the TTMS FNC utils library and then URL encode, which gives me automatic encoding for URLs as they are supposed to be encoded when used in a URL. So that is all that I changed to get the persistence for the Fitbit web API. That significantly reduces the number of times the web browser needs to be started to authenticate. You can reuse an access token, especially with the Fitbit web API. You can reuse the token, I think 2 days, and that's the default setting, without reopening the web browser again, which makes it a very clean and fast process from the client now, without going back and forth between the web browser to get a new access token and so on. This video turned out to be a little bit shorter than the others, but it was just adding functionality to the already existing service, which gives you great benefits for using clients over and over again with the same web service API, because it reduces the time needed to connect. And especially if you use a client several times a day, you don't want to have the web browser open up again over and over again. So this is the solution to make your implementation even better with the FNC Cloud Pak at its core. And if you want to find out more about FNC, go to fnc.tmssoftware.com and stay tuned for the final video of the series showing you how you can use reporting with Flexcel to generate a report and to generate a chart with an Excel template, how to embed the Excel template in your executable file. So that will come up rather shortly.